All right, welcome back. This is 6.1, Points, Lines, Planes, and Angles. So our objectives are to understand points, lines, planes as the basis of geometry, solve problems involving angle measures, solve problems involving angles formed by parallel lines, and transversals. So some defining points, lines, and planes. So we have points, lines, and then planes are like the flat surfaces where you can have points or lines. So a line may be named by using any two of the points. A half line is formed when a point divides a line. A ray is a half line with its endpoint included. A line segment is a portion of a line joining 2 points. So in this diagram below, a closed circle indicates that the point is included, and then an open circle indicates that the point is not included. So angles, they're formed by the union of 2 rays that have a common endpoint. One ray is called the initial side. The other ray is called the terminal side. And then here's an example of that. All right, measuring angles using degrees. So angles are measured by the amount of rotation from the initial side to the terminal side. Angles are measured in degrees, symbolized by the degree symbol. There are 360 degrees in a full rotation of a circle. And then 1 degree is 1 over 360 of a complete rotation. So we have our first example. So it says the hour hand of a clock moves from 12 o'clock to 2 o'clock. Through how many degrees does it move? So moving from 12 to 2 is 2 over 12, or 1/6 of a complete rotation. Thus, the hour hand moves. So it moves 1/6 times 360. So we have 1 over 6 times 360, which equals 360 over 6 because it's kind of like 360 over 1. So 360 divided by 6 would be 60 because 6 times 6 is 36, and we have that extra 10 on there. Or you can do it in your calculator and you'll end up getting that same value. All right, so this gives you some more examples. So an acute angle is less than 90 degrees, right angle is 90, obtuse angle is more than 90 but less than 180, and a straight angle is 180. So protractors are used for finding the degree of measure of an angle. We measure the angle by placing the center point of the protractor on the vertex of the angle and the straight side of the protractor along one side of the angle. We read the degree by reading where the other side of the angle intercepts the edge of the protractor. So choose the number based on whether the angle is obtuse or acute. All right, complementary angles. So complementary angles are 2 angles whose sum is 90 degrees. To find the complement of an angle, subtract it from 90. So the complement of 70 is 90 minus 70, so that equals 20. Supplementary angles are 2 angles whose sum is 180. So the supplement of 110 is 70. So our next example, so it says find the measure of DBC. So from D to B to C. Oh, that went haywire. So we're finding that angle here. So remember that whole thing makes 90 degrees. So we can subtract 62 degrees. And then if we do that, we'll get we'll get 28 degrees. And you can put that in your calculator if you would like to. All right, next we have, it says the measure of ABD is 66 greater than the measure of DBC, and they are supplementary angles. So ABD and DBC, so 66 plus X, and then our angle X. So remember, supplementary angles add up to be 180. So you would do 180 minus X plus 66 plus X. So then you would get 180. Oh, not minus, equals. So let's fix that. So 180 equals 2X plus 66. So then you would subtract 66 from both sides, and then you would end up with 114. So 114 equals 2X. Then you would divide by 2. So you get 57 equals X. So this would be 57. That 5 doesn't look right. Okay. So 57 degrees. So that one means it's 66 plus 57. So 66 plus 57 is going to give us 123. And then we got to check to see if 123 plus 57 is going to equal 180. So if we add those together, we get 180. So it checks out. So ABD is 123 and DBC is 57. I don't know, my brain's writing ahead of itself. 57 degrees. All right, vertical angles. Vertical angles are equal to each other. So it's when two lines intersect, the opposite angles formed are called vertical angles, and they have that same measure. So the angle on the left measures 68, so find the other angles. So this across from here, that's going to equal 68 degrees. And then these two add up to equal 180. So you could do X plus 68 equals 180. So you'd minus 68 from both sides. So we do 180 minus 68, and we get 112. So measure of angle 1 is 68. Measure of angle 3 is 112. And then remember, 2 and 3 are going to be the same. So that means angle 2 is going to also be 112. All right. So we have parallel lines that if they're cut by a transversal line, then we have those vertical angles that are made and our supplementary angles that are made. So parallel lines are lines that lie on the same plane but have no points in common. Intersecting lines are two lines that are not parallel and have a single point in common. So like these would be your intersecting points here. So the transversal intersects those parallel lines. And then these are just some rules for transversal intersecting parallel lines. So you can pause the video and read through all of those. Or like as we go through the examples, you'll see the different types. And as you're going through your problems on your assignment, like you can always refer back to this chart. So if you want to take a few seconds and pause and just read over those so you kind of understand which angles are going to be equal to each other and which ones are not. You can go ahead and do that now. All right, let's go back to here. Notice that alternate interior angles are equal, and then corresponding angles are the same. Okay, chart, because you'll have things that will be matching because the line cuts in the same space on both of those lines, so it will make those same angles because those are straight lines. All right, and then move on to do some examples. So you have also your definitions here. So if you want to pause and read those, it just means the alternate interior angles have the same measure, so they're equal. Alternate exterior angles are equal, and corresponding angles are the same. And then if it was intersected by a third line, those rules would still apply. So if you go back and let me know if you have. All right, so let's do this example. So we're going to use all of those rules that we saw and put those into use. So let's start by doing the one that we kind of know is a guaranteed. So measure of angle 1 is going to be 35. Then we know these can be 180 minus 35. So 180 minus 35 is going to give us 145. So that means 7 and 6 are both 145. And I'm just going to erase these lines here and just put what our measurements are. So 35 and 145s for these. All right, and then remember to get to these next ones over here. So if we were to do alternate, so 3 and 7, so that's going to be 145. Oh, we forgot to write them down here. So measure of, I wrote that backwards. So measure of angle 6 was 145, and measure of angle 7 is also 145. And then measure of angle 3 is also 145. All right, and then we could do our vertical test after this, or vertical angles. So that's 145. So measure of angle 4 is 145. And then these angles, so you can do one of two things. So you can say, oh, okay, those are going to be the same based off of our rules. So measure of angle 5 is 35. Or remember, you can do the 180 minus 145, and you'll get 35 for those. So that means also measure at angle 2 is 35. All right, so just look out for those rules that you have, and those will be able to help you when you're looking at those different angles and things, and any questions. But other than that, you should be good to go. and work on your assignment.